Welcome back, Cat 5 class. In this video, we're going to go over dimensioning in AutoCAD. So this will be Chapter 8 lecture, Part 1. Next slide. Here's an example of a detailed drawing dimension. Again, a detailed drawing is just a drawing of a single part. So now we're going to focus on dimensioning. So for your assignment, you're going to have sometimes only 2 views or 3 views, but in most cases it'll be 2 views where you have to dimension. We will have a layer for dimensioning. The line weight of a dimension is 0.30, 0.35, similar to a green center line or a red hidden line. And just a quick review from the previous chapter. You try and place the dimensions between the views. Try and place dimensions between the views and try and avoid having them on the outside. We can actually move this 0.25 over here to the left, but this is acceptable. Okay, so let's go to the next slide. So just a quick review of the alphabet of lines. A visible white object line will be about 0.50 to 0.60 millimeters in thickness, so it stands out from the other lines like hidden lines, center lines, and dimension lines, which tend to be about 0.30 or 0.35 millimeters in thickness. And later on we'll talk about phantom lines. Phantom lines have 2 dashed lines versus just 1. And we'll talk more about the other types of lines at a later chapter. Next slide. And once again, we have to follow a standard when we are creating drawings. So how we dimension, what text height to use, what type of extension lines, what type of arrowhead size, what type of units we use, whether it's millimeters or inches. It's all defined by the standards, the ANSI, ASME, or international standards. Next slide. Okay, once you complete your views with white object lines, center lines, and hidden lines, you can then go to the Annotate tab when you're ready to dimension. You can stay in the Home tab, and the Home tab does have a minimized version of the Dimensions panel. But if you want the full Dimensions panel with all these options, go to the Annotate tab. Now we do have a quick dimension command, whether you're doing diameters, radii, linear dimensions. This will create a quick dimension, but it's very limited. I recommend you go the long way. Go to the pull down here. If you're going to create a linear, horizontal, vertical dimension, go with linear. If you're going to do an angle dimension, use the aligned command. If you're going to add an angle, an angular dimension, use the angular command. We're not going to use arc length in this class. Radius, so if you're going to give a dimension for the radius of an arc, use the radius command. For circular holes, we're going to use the diameter command. And we're not going to be using jogged and ordinate commands in this class, but here they are. And again, note we are in the dimensions panel. Also here we have this little arrow pointing downward towards the right. If you want to change any options in dimensioning or properties, you click on this downward arrow and it'll get you to the Dimension Style Manager, which we'll discuss in a later slide. Next slide. So once you create a dimension, you're also going to have grips. Just like when you create lines or arcs, you're going to have grips that you can pull on, or you can even right click and make changes. For example, if you want to move the text over to the left side, you can just right click on this grip and it'll give you options. Options to move just the text or the leader with the text. Also, if you want to flip the arrowheads, if you think you can fit the arrowheads inward, you can always right click on the grip and you can flip each arrow individually. Once again, right click on the grip and you can flip the arrow. And anytime you create a dimension, for example, you want to give this vertical dimension, make sure to click on the endpoints or the vertices, and it'll automatically generate these gaps. Okay, so you want a gap between the extension line of the dimension and the object line. Next slide. Okay, when creating dimensions, you do want to have certain options in the status bar on and some off. When you're creating dimensions, you definitely want to have snap mode off, or else it'll snap to your grid. So it may give you inaccurate dimensions. So make sure you have snap mode off. You can tell it's off because it's grayed out. Another one you want to have turned off is ortho. So ortho will limit your movement with the cursor if you have it on. So turn off ortho. One that you do want to have on is the object snap. You want object snap turned on so you can snap to the endpoints of a line, for example. Next slide. Okay, so once again, if you're ready to create dimensions, you go to the Annotate tab. You have a lot more options here than if you stay in the Home tab. The Home tab has a very limited version of dimensions and annotations. So go to the Annotate tab. You have a lot more options when it comes to dimensioning. Here you also have center lines and multi-leader command. So this is to add text with the leader, which we'll discuss more in the last 2 chapters of this class. Okay, so here what I want to focus on is how do you get to Dimension Style Manager? So if you want to make changes to your dimensions, whether it's the number of decimal places, whether you want to make it millimeters or inches, or you want to change the size of your dimensions, whether it's the text height or arrowhead size, you're going to go to Dimension Style Manager. So to get to Dimension Style Manager, you go to Annotate, go to the Dimensions panel, click on this downward arrow pointing towards the right, and that'll give you the Dimension Style Manager dialog box. Now notice here where it says Standard. Once it's open, you'll see Standard. So you have to follow a standard when you're creating dimensions. So at work, when they give you a drawing template to use for your drawing, they'll be following some standard, whether it's the ANSI, ASME, which are the American standards, or the ISO, which are the French international standards, or it can be the Japanese standards. So you have to follow a standard. It can also be a company standard, like Boeing, for example, Boeing standards, or your company standards when it comes to creating dimensions and annotations. One thing I do want to discourage you of using is overrides. So sometimes you need to do a quick override on the standard. You're going to deviate. So you do a override. If you click on override, it'll branch off. And one simple example is, let's say maybe you want to, instead of use 2 decimal places for this one or a few dimensions, you want to use 4 decimal places, which is common for a whole size, for example. Then you can do a temporary override where you're not following the 2 decimal places for inches. Instead, for precision, you want 4 decimal places, so you would do a temporary override. Go to Modify and change to 4 decimal places. Again, I want to discourage you from using overrides, temporary overrides. Once you get comfortable making changes to your dimensions to deviate from the standard, then I'll go ahead and start using overrides once you get comfortable with dimensioning. Okay, so click the standard you want to modify. In our case, we only have one to choose from. And we'll click Modify, and that'll allow you to make changes to your dimension style. Next slide. Okay, so once you clicked on Modify, so if you want to make changes, for example, to the line type, which we'll never do, we'll always leave it as continuous lines. We're not going to use hidden or center lines for our dimensions. So this area we're never going to change. If you wanted to change the color, deviate from the color. And in our assignment, I chose cyan for dimensions, but you can always change the color if you like from here, or you can change it from the layer properties. So this you'll never change. Chances are you'll never change it. Okay, another thing I wanted to point out here is, again, we are in the line tab. These are already set for you. So if you want to change the length of the dimension beyond the arrowhead, so we're focusing on the extension lines, how it extends beyond the arrowhead. Here it's set. And again, there's no reason to change this. you just leave it alone. It's following a standard, whether it's American or international standards. The offset, so the gaps. So the gap between the dimension line and the object line, so these gaps are 0.0625 inches. I think on the previous chapter I said it was 1/32 of an inch. I need to make a correction. It's 1/16 of an inch, which is equal to 0.0625. So those are the size of the gaps between the extension line and the corner of the object. And once again, chances are you'll never have to make any changes on the Lines tab options. Next slide. Okay, if you want to change symbols and arrows, how they're represented on your drawing, you go to this tab. And once again, you're never going to be changing this. If you think the arrowheads are too large or too small, this will allow you to change the arrowhead size. Arrowheads are about the size of the text height, which is about 0.18 or 0.16, depending on which standard you're following. And this is something you never want to change, but if you do, you can change the arrowhead size. And again, I emphasize don't change it. If you want to create a dimension, whether it's a radius or diameter, when you add the radius dimension or diameter dimension for the circle, it'll automatically generate a center mark with extension lines if you have this option on. If you go with just mark, it'll just show you the little crosshair and remove the extension lines on your center line. And if you don't want AutoCAD to auto-generate a center line or center mark, you just go with none. For your assignments, I chose to leave it as none. So it'll just put a little point at the center and you'll have to manually draw your center lines. But if you want AutoCAD to auto-generate center marks with extension lines, anytime you add a radius or diameter dimension, then click this one. So this is optional. Leave it up to you which way you want to go. Some of you will prefer to have it off and just draw your own green center lines. Others will prefer to auto-generate those lines when you use the radius or diameter command. And here are some more options, things that you can change, but again, you'll never have to change these. Typically, you just leave them alone and it'll be set by your company standards. Next slide. Okay, let's take a look at the text tab. As I mentioned, text, if you're following the standards, are about 0.18 or 0.16 in height in inches. If you're dealing with millimeters, it's about 3 millimeters. Again, it all depends which standard you're following or company standard. Again, you don't want to change text height. One thing you do want to keep is horizontal dimensioning. So that means that the text will always be horizontally oriented. Architecture, I don't know if they still do, but in the past they would have align dimensions or follow an international standard where the text could also be oriented vertically if you were doing vertical dimensions. But we're going to leave ours as horizontal. All right, once again, don't change anything in the text tab. Next slide. Okay, fit tab. So fit options. So if your extension lines, your text, and your arrowheads are too tight together, AutoCAD will automatically either take out the arrowheads or take out the arrowheads and the text or just the text. So this is something you want to leave alone. It'll just do a best fit for you if you pick this option. If it gets too crowded and you only want to move out the arrowheads, then you can have the option to either move out the arrowheads or the text or both. I tend to just leave it as a best fit. It'll automatically place the text inside or outside depending on how much room there is between the extension lines. So leave it alone at best fit. If it doesn't come out the way you like it, you can always manually, using the grips, bring the text in or out. Same thing with the arrowheads. Now, this is very important. One thing that you may have to change is the overall scale. Now, when you go work for a company, they should have a drawing template for millimeters and a drawing template for inches. If they don't, if they just use one template for both, you may have to go in and change the overall scale. So one good example is what happens if your text and your arrowheads and your dimensions are just very tiny. You throw in a dimension and you can barely see it. It's so tiny. One thing you don't want to do is change the text height or the arrowhead size individually. What you want to do is go to overall scale. That will automatically change the gaps, the extension, the arrowheads, and the text height, change them all in one shot. Okay, so if your arrowheads are really tiny, the gaps are very tiny, the text height are very tiny, you can barely see it. Then you go to the Fit tab, go to Overall Scale, and maybe try 10. Try and use nice round numbers. Try 10 and it'll increase the size of everything by a factor of 10. It will not change the feature size. It'll leave it as 1.00, but the arrowhead, the text height, the extension, the gaps will all increase by a factor of 10 if you type in 10. Okay, so keep this one in mind. You may have to change overall scale if you can barely see your dimensions or too tiny in size, or they may be too large, crowding your drawing, and you may have to reduce the scale factor. Next slide. Okay, so once again, just a quick reminder from the previous chapter. In the title block, you always have to call out which unit you are using. So in manufacturing, machine shops, metal forming shops, aerospace, automotive, 99% of the time you're going to be using either inches or millimeters. Here in America for architecture, they tend to use inches. Some old drawings use feet inches with fractions. Now we're going all to decimal places, to decimals. One thing to keep in mind is 1 inch equals 25.4 millimeters. So if you ever have to convert your drawing, if your boss tells you, hey, I need you to change your drawing from inches to millimeters, remember that 25.4 millimeters equals 1 inch, and you may have to multiply your dimensions by a factor of 25.4. So let's talk about that. Next slide. Primary units. Now on the Fit tab, on the previous tab, the Fit tab, 2 slides ago, we mentioned about having to change the size if you can barely see the dimensions, if they're too tiny in size, then you go to the Fit tab and change the overall scale. But if your boss tells you, hey, I need you to change your dimensions from inches to millimeters, so instead of 2.02 inches, your boss wants you to change this to millimeters, about 51 millimeters. Then you have to go to scale factor. You go to scale factor, and you would change the 1 to 25.4. So by changing this to 25.4 scale factor measurement scale, it'll multiply every number, not the angular dimension, but the linear dimensions and radius dimensions will all change by a factor of 25.4. So 2.02 times 25.4, that would be roughly about 51 millimeters. It'll take 1.02 multiplied by 25.4, giving us just under 26 millimeters, and so on. This one will stay the same. The angular dimension will stay as degrees. If you also want to change the number of decimal places, you go to Precision, go to the drop down, and if you're creating a inch drawing, so drawing with units of inches, you typically want to go with 2 decimal places for all dimensions. If it's a circle where you need precision, accuracy, then you may go with 3 decimal places or 4 decimal places. But for inches, typically you go with 2 decimal places for all your dimensions. And then from there you can deviate. You can go to 3 or 4 decimal places if needed. Remember, the more decimal places, the more accuracy, the more expensive the part gets. Now, if it's a drawing created in millimeters, then you want to go with no decimal places. You want to pick the first one. It'll just use whole numbers and no decimal places. Once in a while, you do need to include one decimal place for accuracy when you're in millimeters. Okay, so millimeters go with no decimal places. Inches go with 2 decimal places. Okay, one thing that I have not mentioned, or maybe I did on the previous chapter, is suppressing zeros. Suppressing leading zeros. What does that mean? When you click this on, it'll drop to a 0. So instead of having radius 0.80, it'll drop to 0 and it'll give you radius 0.80. Now the rule is if you're dealing with inches, you suppress leading zeros. So if you're dealing with inches like we're doing here, turn this on and it'll drop to 0 in front of any number smaller than 1. If it's millimeters, you do not suppress 0, so you would uncheck this mark. Okay, next slide. Once again, you typically point out whether you want to use inches or millimeters for your drawing. That'll be listed in your title block. Again, you have to list in your title block which units you're using. Okay, so in the rare case where your boss tells you, you know what, for clarity, we're going to use inches and millimeters. Millimeters will be secondary. So what you can do is you can turn on display alternate units. Make sure your multiplier is 25.4 because there are 25.4 millimeters in an inch. So when you click on this option, turn on display alternate units, it'll show as 2.02 inches. And then in parentheses or brackets, it'll show 51 millimeters. Same thing with the other dimensions. It'll show the primary units, 1.02 inches, and then in parentheses, it'll show the millimeters, 26 millimeters, for example. The only problem with this is that it will crowd your drawing because now you have double dimensions, the inches and the millimeters. It's rare to see this, but in the rare occasion, sometimes there will be a request to show both inches and millimeters. Next slide. I'm only going to briefly mention tolerances in this chapter because we will spend 2 chapters on just talking about tolerances. Just don't forget that tolerances, for now, tolerances is how much the part can be off by. So when you ask a machinist, hey, I want the thickness of this metal plate to be 1.00 in thickness, the machine shop is going to ask, well, how much can we be off by? You have to give them wiggle room. So this is referred to as a tolerance. So here you're telling the machinist you can be off by, from the 1 inch thickness, you can be off by 0.03 or 0.030 thousandths of an inch in either direction. So this is the wiggle room you are given the machine shop and also the inspector. When the inspector measures the thickness of the plate that was machined, they want to know how much they can be off by, and that's referred to as a tolerance. And again, we'll talk more about this in a later chapter. Next slide. Sometimes you need to make changes to the dimension. One good example is sometimes you have to fake a dimension. So let's say you dimension a part, but for some reason, maybe because of the view you're looking at, the perspective, whether it's maybe an auxiliary view that's not giving you an accurate view of the part or the feature. When you dimension it, sometimes the dimension does not come out correctly. It's rare, but it does happen. So sometimes you have to override a dimension. So all you have to simply do is double click on the dimension on the text. You can highlight it. And let's say you wanted to type in 1.5. So you just double click and with the mouse highlight the text and type in 1.5 and it'll overwrite your dimension. Also, you need to sometimes add symbols like diameter or counterbore or countersunk symbols for a hole or for a cylindrical solid shape like a shaft. You need to add a diameter symbol. When you first double click on the text, you'll see your cursor blinking. in the front. You can always use the arrows on the keyboard or simply click on the back if you want to add a symbol on the back. So again, it defaults by blinking here at the front, and you'll have the option to insert a diameter symbol, which I'll show you on the assignments when I show you how to do each one step by step. Also, another thing, maybe you want to change decimal places. So again, if you're doing a drawing using inch units, typically you go with 2 decimal places, but if you want accuracy, precision on a hole, like a circular hole, then you may go with 3 decimal places or 4 decimal places. And you can simply do that by right-clicking on the dimension, and you can change the precision and go with more decimal places. Once again, you can always click on the dimension once. The grips will light up, allowing you to make changes like flipping an arrowhead, or maybe moving the text outside the extension lines. So again, double clicking or right clicking will give you options to make changes to the dimension. You're basically overwriting it. End of lecture.